Hi there. Today we're going to look at circles and arcs that they create. And we just have some of the things today are going to be some terminology things. So let's just look at this circle that we have. We have the center of the circle, which is going to be the center point that the circle's created around. AB is a diameter. It goes all the way across the circle, goes through the center. A radius also goes through the center, but it only goes halfway across. And then really what's maybe the new thing is going to be this term, this central angle. It says angle APC. APC, this angle that's marked here, that's a central angle. Any angle that comes from is created by the center and two radii, that's a central angle. So right here, this would be a central angle as well. Now, when we're dealing with arcs, we have two types. We have major arcs and minor arcs. An arc is a portion of the circle. So right here you can see that this is a portion of the circle. It's an arc, but it's a smaller arc, so it's called a minor. If you're talking about an arc that goes over halfway around the circle, then that's a major arc. If it's less than halfway, it's a minor arc. So let's look at some questions that you might have on your homework that says, what are the minor arcs of circle A? That's the notation for circle A. Okay, minor arcs would be anything less than halfway around. So I'm just going to start going. I could go Q to P. I could go Q to S. I could not go Q all around to R. That's over halfway. Now notice another thing I didn't mention here. If you're only using a minor arc, you just have to use the two letters and you put an arc over the top. But if you want to indicate that it's a major arc, you're going to have to use three letters as you and they have to be in order as you wrap around that circle. So you can see, well, actually they started at S, went to T, then to R. All right, so on these minor arcs that we're doing, we're only going to use two letters. So back to what I was doing, Q to P would work, Q to S would work, but could not go around to the R. So let's just start listing them out. I'd have arc QS and arc QP. Those are the two we talked about. All right, then let's go to a different letter and let's see what we can do with that. So I'm going to go to start at the P. I could go P to S. That would work. P to R actually would not work. That's going to be a semicircle. If it goes exactly halfway around, and I know it does because it's this diameter here, then we call that a semicircle. I would not call that a minor arc. So I'm going to go ahead and write arc PS. That one works. And then I'm going to go ahead and answer part B. The semicircle would be arc PSR as you wrap around. Now, you can also wrap the other way. Instead of going this way and talking about this portion of the circle, if I wanted to use this portion of the circle, then that would be another semicircle that's different than the previous one. So I'm going to go ahead and add that in. That would be PQR. Doesn't really matter if you go clockwise or counterclockwise as long as you get them in order as you would hit them around the circle. Okay, let's go back to see if I can come up with any other minor arcs. So I started from Q, started from P. What about starting from S? Couldn't I go SR? Wouldn't that work? Could not do around to Q. That's too big. So I think I could do SR as a minor arc, and then I'm going to go RQ would work. R all the way to P would not work. So I've got a couple more. S to R. Let's add that in our list. So we call that arc SR. It's the same as arc RS. I don't need to write it twice. And then I have also arc RQ. Those are all my minor arcs. Then I got my semicircles, and then it says major arcs that contain point Q. Okay, so they're going to be picky about it, or just very specific. They want it to only include the Q. So I could go Q all the way around to R. Now that's actually could be used, I could use 4 different letters there, but we pick out 3 of them. So I could call it Q, then P, and then R, or I could go Q and then S and then R. Either one of those, it's the same arc, but we only use 3 letters. I'll go Q, S, R. That's a major arc. All right, and then I can also go the other way around. I could start at Q and go this way. To R is still a minor arc, but if I went clear to S, That would be a major arc. So let's go ahead and write that one. I'll call it QRS. All right, and then I actually have one more that I could do, starting at Q, going this way around, all the way around here to P. That could work. So I'm going to call that Q, and again, I can choose between the R and the S. I'll guess I'll go ahead and go with the R, and then on around and end at P, like that. All right, just a little introduction to what these major and minor. Right, so now let's look at some measurements on these arcs. We call this the arc measure right here. The arc measure is how, when you are labeling how big that arc is, the arc measure is exactly the same as the central angle that creates it. So if this is a 50-degree angle, we say that the measure of this arc is also 50 degrees. This is the measure of the arc RT is the same as the measure of the angle RST, the central angle that creates it, and it's 50. Now, you can find other things if you know that that's 50. We know that it's 360 in a circle. So if this little piece, this little central angle is 50, then the rest of this Pac-Man shaped thing would have to be 310. So you can see they've done that down here. So then the measure of this major arc, RQT, or TQR as they've called it, okay, the blue arc would have a measurement of 310. Let's practice seeing if we can find some of these. You're going to want a calculator for today's homework because not all the numbers are going to be that easy to work in your head. You're just going to have to kind of remember that it's 360 all the way around, which means it's 180 if you have just a semicircle. So you can see right here I've got this diameter, so it is creating a semicircle here and a semicircle here, and I would know that those are both 180. You can see here that they've labeled this arc to be 28, which is ultimately the same as saying this angle is 28. And vice versa, here they give me the angle is 77, which tells me the arc is also 77. All right, I think I'm going to start off, and I'm just going to fill in everything I can. Since this creates 180 right here, I know that the 77 plus something has to equal 180. So I'm going to type 180 minus 77, and I'm going to get 103. And I can do that same thing. I'm going to go ahead and put my 77 on the outside there, and then I have my 28, and I'm going to do the same thing for my arc PQ. Again, it's part of a semicircle. This much is 28. What's left for the rest of the 180? So you subtract that out, and you get 152. I'm going to throw a 152 out here on the outside of that arc. Oops. Like that. Now, let's go answer some questions. It says, what's the measure of arc PR? Okay, well, it's the same as the central angle, so it's 77. Got it. Okay, how about arc RS? Well, we went and found that one. We found that to be a 103. All right, the next two are major arcs. I know that because they have 3 letters. So P, R, Q. So from P to R all the way to Q. All right, so I'm going to have to add the 77, the 103, and the 28. All right, let's see what we get when we do that. All right, I have it 208 degrees. All right, why don't you do that last one? See if you can find the measure of arc PQR. I got a 283 degrees. I'm going to add the 152, the 28, and the 103 to get that major arc. Oh, hey, here's another thing you could have done. Instead of having to add all 3 of those up, could we maybe also have instead said, well, it's almost all the way around, and all the way around would be 360. I could have done 360 minus the piece that's not included, minus the 77, would have still gotten there. Might have been faster that way. Either way works. Okay, here's just a term real quick. Sometimes they'll talk about these concentric circles. Concentric circles just means it's two circles with the same center, so they're going to be different sizes. You have this little one right here, and it is concentric with this outer one. It's kind of like ripples on a lake or a target kind of thing. That's what concentric circles are. Now, where this is leading for us is to do a little bit with these arc measurements and looking at how that might compare to your circumference. Remember that the circumference is the distance all the way around the circle. And there's a couple formulas that you can use. It kind of is a personal preference. You can say the circumference is equal to 2 pi r, or you can just say it's pi times the diameter because the diameter is twice the radius. Either one of those works fine. I typically use the one that just depends if they give me radius or diameter, and I use that one. But whatever works for you. This says that a car has a circular turning radius of 16.1 feet. And the distance between the two tires is 4.7 feet. How much farther does a tire on the outside of the turn travel than a tire on the inside? Okay, so you can probably think like on NASCAR, they probably wear out one set of tires more so than the other set because they travel farther. Okay, so if you look at what they've given us, they told us that the full radius of the big circle, the outer tires here, would be a 16.1. But that the distance between the tires is 4.7. So if I'm dealing with the inner circle, that radius would be less. That radius would actually only be, I would do 16.1 and I'd subtract the 4.7 and I have a radius of 11.4. Okay, that's a 4. What a mess. Let me fix that. Okay. Now, how much farther does one turn or spin than the other? Well, let's just find the circumference of each of them. So I'm going to start off and I'll find the circumference of the big circle. And they've given me radius, so I'm going to do 2 pi times the radius originally was 16.1. And then I'm going to compare that circumference to a 2 pi times 11.4, which is the smaller radius. We just multiply those together and see how much farther does it go. So 2, and you might have a pi button on your calculator. Get used to using that. It makes it a little bit faster. All right, so on this one, my circumference is 101 point, let's just go 1 decimal place, I guess, since they did. And then over here, the circumference is 2 times pi times 11.4. And I have 71.6, and then I would subtract those. And I'm left with how much farther? I'd say 29.6 feet farther. Just by subtracting those. Okay, so we're going to use this circumference formula a bunch. I just wanted to practice a couple times using it. Because the next thing we're going to move on to is we're going to talk some more about these arcs. And you can talk about the measure of the arc, and that references how big the central angle that creates it. But probably more importantly is to know what the length of that arc is, just like on my card problem. What if I didn't go all the way around the circle? What if I only went part of the way? Well, I'd want to know what that length of that arc is. So like in this example, I would want to know just this portion, not all the way around. So let's just do some common sense stuff here. It says, assume the circumference is 12 centimeters. What do you think the length of arc AB is? Well, AB here is a semicircle. So if the circumference was 12, what do you suppose the arc length here would be? Okay, it'd be half of it, because 180 is half of 360, so that arc length would only be 6, half of the 12. Okay, let's look at this example. Let's pretend this is a right angle here. How much of the circle am I using here? Okay, well, because 90 degrees is 1/4 of the all the way around, this arc length is going to be 1/4 of the circumference. So it ended up being 3 centimeters. So the whole idea here, why we're doing this, is they're not always going to be perfect like a semicircle or a right angle, but it does have everything to do with this central angle here. whatever fractional part of this central angle is compared to the entire circle, to the 360 degrees, well then that ratio will be the same for this arc length versus the entire circumference. All right, so I've got this slide here that this is an important formula for you to know. But if you want to find the length of the arc, how long is this arc? Okay, you're going to take your central angle measurement, and I pulled this just off a Google picture, but this is your central angle. It's a Greek letter. When you get into higher level math, we use a Greek letter for that angle, but it's the central angle, whatever that measurement is, divided by 360. Okay, so you're saying what portion of the circle is this angle? So you divide it always by 360. And then you just take that fraction times your circumference. So if this was a 1/2, I'd take half of my circumference. And I would know it's a 1/2 because it's a 180 over 360, or end up reducing to 1/2. So this is our formula for arc length. Let's find the length of each arc shown in red. Leave your answer in terms of pi. So I'm not actually going to type in pi or 3.14. I'm going to leave the pi in my answer. It's kind of our way of leaving it exact. Okay, so arc length. Okay, it's going to equal the central angle, and I'm looking at this arc right here, so the central angle is this 90 over 360, and multiply it by your circumference. Now your circumference formula, remember, is either 2 pi r, or you can just do pi times diameter. So just depending on what they gave me. So in this first example A, they actually gave me the diameter, so I'm going to multiply it times pi times diameter. Okay, now 90 over 360 is really just 1/4 of the circle, and recall we've done this before, that you're just multiplying these numbers together. The order you multiply them doesn't matter. I'm going to go ahead and just do some quick mental math. 1/4 of 16 is just 4. So this would reduce to 4 times pi, and we would leave pi in your answer. Your units for this are just, it's a length, so it's whatever anything else measured length is. So in this case, it's inches. Okay, see if you can do this next one. Use your formula to find the arc length. Now notice you're doing the red arc here. It's the big one. It's the 240. Okay, go ahead and pause the video, work through your formula. All right, here's what I got. Left it in terms of pi, just 20 pi is what I ended up with. Now hopefully you got your numbers all put into your formula correctly right here. Now you may choose to not mess with reducing that. We've just gotten some nice numbers, so they've always been reducing nice. If you didn't reduce it to 2/3, you're going to be okay. If you just typed it in your calculator, like what you could have done is typed in your calculator, 240 divide by 360 times 2 times 15, and you would have ended up at that 20 right there. All right, so that formula is not too bad to use. I'm not going to do a whole bunch of examples. You just kind of plug in the numbers and go. I just wanted to spend a moment here to clarify, because they're going to ask for, sometimes they're going to ask for the measure of the arc. If they use the word the measure of the arc, that means and they use a little m here to show measure of the arc. That's the time where it's just the same as the central angle. If they actually use the phrase arc length, they actually want to know how long it is in comparison of the full circle in the circumference. And so arc length is when you're going to be using your new formula. So pay attention to the wording on that. All right, go do your homework. Good luck.